We are going to be 10 billion by 2050. We are going to live on a planet 4 degrees hotter. We are going to have more mouths and less food. We are going to have less land and more pollution. But we crossed oceans and we defeated diseases. But we went to the moon and we blossomed the desert. Because we are innovators. We are farmers. We are makers. We are dreamers. And we are going to gather and discuss, create and inspire minds and souls. Because we are feeding our future.
"14 million square kilometers. Do you know how much that is? No? Then I want to make an experiment, do an experiment with you, one I saw from Professor Mitt-Lerner at University of California in Davis. And take a sheet of paper, you all should have one. Okay? So now let's fold this sheet of paper in two. Oh, this is our planet. Well, it's flat, but still, imagine it's our planet. And now I want you to take this sheet of paper again and fold it again in two. Okay? This is the amount of immersed lands that we have, without any water in it. So seas, oceans, rivers, lakes. Now I want you to take this sheet of paper again and fold it in three. Okay. This is the amount of agricultural land that we have, including marginal lands, pastures, and the agricultural land where we grow our food. Now I want you to take this sheet of paper again and fold it again in three. And this is the arable land that we have, the land that is actually suitable to grow our food upon. And this is 14 million square kilometers. And what we do with this impacts everything that's around us. Waters, seas, oceans, all the other land. So now what do we do with this? And how can we feed and we grow enough food on this for a population that is growing? Some estimates say that before 2050 will be 9 to 10 billion people. And the most growth is occurring in developing countries, Asia or Africa, where already today 800 million people are suffering from hunger and starvation. So how can we feed everybody? How can we bring enough food? Or how can we teach those populations to grow enough food for their own sustainability, for their own sustenance? What is the solution? The idea of transferring and teaching them to do what we are doing now can be an idea, but we all know that intensive agriculture, as we know it today, is creating a lot of problems. Dr. Wilkinson already highlighted how much agriculture pollutes the air and contributes to greenhouse gas emissions and climate changes. These are just some images. Take the first one on top. This is an ESA picture of the Po Valley, right where we are now. And this is not air pollution. This is ammonia. Ammonia is mainly emitted from agriculture. And despite ammonia not being one of the greenhouse gases that we know and everybody talks about, is strictly connected to particulate matter formation. This is a problem that we are facing now, because particulate matter is what creates problem of asthma, respiratory, breathing problems to our children, my children. The second is water pollution, eutrophication, not having enough fresh water. And this is again caused mainly by agriculture. Leakage of nitrogen from manure, from excess of fertilizers. What does that mean? Is that, again, intensive agriculture is creating soil degradation. Again, this piece of land is reducing, is shrinking, while the population is increasing. What does that mean? Is that people around the world, especially in developing countries, are trying to find new lands and deforestation. Again, we are taking out one of the lungs of our planet. So, are there alternatives? Are there a solution? This is a summit of innovation, so we know that there are, I don't know, backyard farming, city gardening, vegetarianism, or other sources of protein. These are a very good solution. They can be a very good solution for cities, maybe, but if we think of developing countries, they are already, most of them are farmers already. Most of them already eat mainly vegetables because they can't afford meat, but they would like to afford meat. President Obama yesterday said that a lot of developing countries, as soon as they reach middle-class incomes, would want to eat meat. Why shouldn't they? And other sources of protein, again, if we think of Asia, insects or other different kind of protein sources are a normal part of the diet. So these are not actual solutions for them. Our idea is that a different model of intensive agriculture is possible. And that's what we call sustainable intensive agriculture. How can we achieve that? This is by acting and interacting with a small ally that has been kind of neglected by traditional agriculture so far, which is the microbiome. Microbiome that we can find in the soil and on the plants, microbiome that we can find in the animals, in the guts animals. It's inside us as well. Microbiome that we can use and we can have as an ally to exploit and to valorize manure and animal effluents. Actually, it's what our company has been doing for the past 15 years. Create products and solutions that could interact with the local microbiome of the different realities. This allows us and allows our farmers to reduce the inputs with less chemical fertilizers and agrochemicals, reduce the amount of feed to grow the animals that people want to eat, and at the same time increasing the yield. So this overall translates into an increased efficiency throughout the entire food chain. So from the soil to your plate. And this also enables our farmers to increase their profits and lower their costs. Because as President Obama yesterday said, there's no point in having a technology that is not affordable or is not economically viable for farmers or for growers, especially in those poor countries. And on top of that, the possibility to reduce chemicals, chemical fertilizers, the amount of feed, of food required, enables us to reduce our impact on the environment. I want now to show you some of the results that we are having. This is a time lapse of barley. 2 seeds of barley placed on 2 jars with actual agricultural soil, the standard cultivation method and with the SOP method. You see how faster the plants are growing, how faster and stronger they are developing, already in a few days' time. And look at the root system. This is the mouth of the plants. If they have larger mouths, longer and stronger ones, they could resist better to heat stress, for example, and Mr. Buckley was suggesting, and having and exploiting better whatever nutrients that you feed them. And also the amount of soil microbiome that grows around them helps them throughout the entire cycle of the plant. This is another example, a tomato plant, and just to make a good plate of pasta. And this is a young vine plant. Again, a new time lapse. On 60 days, you could see how faster the new blooms are blossoming, the new leaves are sprouting. And again, by exploiting the ability of the soil microbiome to convert whatever nutrients the plant needs into a form that is stable, that is there, that is not going to leach into fresh water, groundwaters, creating all the troubles that we've seen before. Of course, we need to feed the plant, but we can feed them less. The results are incredible. And the thing is, once the plant feels that the environment around it is healthy, is stronger, is full of nutrients, then it simply grows better. But what's the point of producing food if then it goes to waste because you can't preserve it? This is another example of simple bread inoculated with a very large amount of mold, so it's nothing comparable to what you can have in the normal production facilities. But this is an example of how conditioning microbes that are from the environment, in the environment, can help us to save food. Let's move now to real cases, real farmers that are actually using our products. So again, standard cultivation methods, again, our kind of treatment. And this is the example of root system that could be achieved not just on annual crops, like corn or barley, like we saw, but also on perennial crops, orchard, improving the amount of yield, improving the quality of the final produce. And all of this could be obtained, and is obtained actually, from our farmers, with a reduction of chemical fertilization. This is important. This is, besides the cost for being a cost for the farmer, is something that can create, and is creating, as Mr. Wilkinson said before, problems to the environment. Pollution. 33% in the first year compared to the standard cultivation. 55% in the second year, and up to 60% in the third year, compared to standard cultivation, to obtain actually even a better production. So this does not come at the expense of production, and does not come at the expense of the farmer's profitability. These are other examples. Mr. Buckley correctly said that milk and beef and meat are one of the main polluting sectors for our world. So what if we can increase the productivity of meat and milk with the same resources we have, both in milk and in meat? And this is done in the Po Valley again. This is one of the most productive areas in the world for milk. We're not talking about India, where the milk production per cow is actually 5 liters, not 35. And this is an example of how, on a real farm, feed efficiency is measured. These cows are simply eating less for producing the same amount of milk that this farmer is supposed to be, giving again a saving in cost for the farmer and a saving of cost for the environment. At the same time as well, conditioning the microbiome from the manure, we could also reduce the emission gases that come from that. And it's all a microbial activity. If we can condition the microbial activity like this, we could reduce the emissions. Ammonia, like we saw in the Po Valley, ammonia that comes from the manure. Actually, with Professor Mitlone, we are studying also what the impact of our product, and certifying that, what can impact of our product have on the greenhouse gases. Also, at the end of the presentation, I would invite you, everybody, to sniff some of the cow manure that we placed just close the exit. And an indirect benefit of our product is also that since we are working only with the microbiome, we don't need actually great amount of products to feed the plants. We just need to condition the microbes, and then they will do the work. So the idea is, transportation-wise, if we consider carrying around fertilizers around the world and around the countries just to feed the plants, one single truckload of our product is able to replace, with the same decrease that we saw before, more than 500 truckloads of urea. And this is another positive and important impact that we can have on the environment. So we do have an idea of what to do with this piece of land, and I would invite you all to our booth to discuss about that. Thank you, everybody.